So I want to go ahead and walk through 11.1.13 and how I would look at doing that. The first thing you need to understand is what is an X bar and an X bar bar chart. X bar is basically taking the average of a single day's events. So you take all the runs during the day, we get an average of those runs. So the data from the machine samples is, on average, each day our machines were outputting at this level of thickness, 1.357 inches, 1.378, etc. An X bar bar is the average of averages. Sometimes we want to see is, even if our average shifts a little bit during the day, is the overall average of those averages consistent? So to find out the X bar bar, we take the average of all of those different numbers. So we'd go ahead and put that into Excel and type in all those different numbers and see what it would look like in terms of those averages. So I'll go ahead and walk through that at the very end, but I'm just going to keep going through the exact questions as well. So let's just go ahead and click into preview and see what the questions are going to be. So the first one is, what's the X bar bar? So the average of all those numbers will be the X bar. What's the standard deviation of the means? Again, that's the standard deviations of those X bar. So we can go ahead and do that in Excel. We can add all these different numbers, calculate the standard deviation of those numbers. And then we have upper control limit and a lower control limit. Normally, we multiply those by some statistical threshold to be able to have a specific threshold of success. In this example, we had to get that information from 11.12. So if we go back to 11.12, it says based on the standard distributional curves, we can look at what a 99.7% area coverage would include, and that includes 3 standard deviations from the mean. So basically, we're trying to say we want to stay with plus or minus 3 standard deviations of the mean for this example. You can change those thresholds based off of how close it is. Sometimes you'll choose upper lower control limits by how important it is for you to stay within certain ranges. Sometimes the lower's closer, sometimes the upper's closer. Sometimes being too small is okay and being too big is really bad. So you can those kind of depend on circumstances. In this example, they're talking about what happens within 3 standard deviations of those curves. So we would just be able to take the X bar plus 3 times that and minus 3 times that would give us the means, the upper control limit and the lower control limit. And then we get to data number 2 and we say, okay, well, now we're looking at, here's the sample means, and question 2, show this data in the chart format. So you can insert the chart and you can see what it looks like in terms of a line chart, and you can see the series of information. You can look at the X bar, the low upper control levels and the lower control levels. Upload your chart and then look at it compared to the feedback on this one. Make sure your data looks similar to the way the data was graphed here. Question 3. We now collect and we do it again. So this is from 30 observations on one day. So what that means is we're taking the average of that one day, and that's going to become an X bar. So we would collect all of these. We would take the mean of those, and it would come up here, and it would become day 21. The mean of all of those is the X bar for day 21. You can look and see, is it still producing quality outputs based off being within the upper and the lower control limits? And it's going to be below the lower control limit. So what should we do about the new sample, right? In general, you need to adjust the production process to be able to align it. Either there's 2 ways you can do that. One is by reducing the standard deviations, so you can make the process more accurate, or you can shift the overall layout of where it is. So based off what the actual number is, because we're below the lower control limit, my guess is we probably just need to shift the manufacturing to make it slightly larger. Yep. And then question 6 is going to be, oh, it looks like the machine was bumped by a forklift, so it's out of calibration. So you need to recalibrate it. And the new mean is taken, and the sample is 1.364. So do we want to see, is this within the upper and the lower control limits where we'd expect it to be? And if not, we need to adjust it accordingly. Looks like this is going to be kind of high. Nope, it's going to be about right. 136, 136, 136. It looks like it'll be pretty much in line. So we'd expect that to be the case. We can go back and go through all the different numbers now that we've gone through the logic, and it should make a lot of sense. What I'm going to do is I'm going to make sure we have an Excel screen. So I'm going to add another screen real quick. All right, so now I've got Excel operating up here. Make it a little bit smaller so you can see both the questions and the Excel, so you can see how we're doing this. All right, so we take all these different numbers, move them over to Excel. I don't really love this format where it's going that way, so I'm going to grab them all over, line them up. I'm going to transpose them so that they're vertical, so I'm going to paste them. Should be able to transpose them. Here we go. Transpose those. Make sure these are reading across as numbers. Okay, looks like we're good. So I can select those and I can see what the average is going to be, 1.356. But we're going to use Excel to calculate things. So average of those days. And that's going to be the X bar. And these are all X bar. And we have day 1, 2, 3. 1, 2, 3. And just go ahead and drag that down to there. And we can calculate the standard deviation of those. And then we got those numbers. So let's go ahead and put those in. Question 1. We got to have also the upper control limit and the lower control limit equals this. Oh, it's supposed to be 1.36 inches wide. So instead of using the X bar as the center, let's use 1.36 inches wide plus 3 times the standard deviation. I'm going to hit F4 to fix that into only reference that box. And then I'm going to do that, copy that over again, and this time I'm going to do minus. So we have an upper control limit and a lower control limit. We want to be between 1.39 and 1.32. And that's where our output should be, give or take. So let's go and put those numbers in. Probably don't need that many, but we'll see. A little bit of rounding there, we'll see. Show this data in a chart format. Let's grab this line, insert it, make it into look like a line. Let's grab this one then. You can kind of see where it's bouncing up and down, and hopefully we're staying within the upper control limit. 1.39 at the top, 1.32 near the bottom. Looks like one of them fell below it, 1.321 right here. Day 5 was below where the lower control limit would be. So that one would give us a warning sign and would say, oh, we got to pay attention. And it looks like it was corrected right afterwards and restabilized. So we could upload that picture. Yeah, we also can add, looks like the way they want you to produce this is having the upper control limit as a number here, and the lower control limit as a number here. You can actually see what that looks like if we grab this data, we spread it out to include the upper and the lower control limit lines. Oh, I gotta start over, I guess. There you go. So you got the upper control limit, the lower control limit, the bar deviating. You can see where it went under. Oh, and we want to have an X bar. So we can just add another one here. Value. And then we've got all 4 that they're asking for in here. And it's just right in the middle. There you go. So we'd upload that file. Put it next. And we add 30 new collections. So we'll grab all these different collections, go back to Excel, take these, move them into a nicer format, move them over here, move them over here. Grab this, transpose it because I think vertically for some reason. And there's the average, 1.319. Make it calculate it correctly though. Average of those. Grab this, grab that value, paste it as a value, call it day 21, and we can shift the averages down. So it's asking what is the mean of the sample though, right? So we just grab this number, boom, we got the mean. All right, is the process still in control? Well, let's see. 1.319 is below the lower control limit. Nope. And what should we do? We need to change something. We need to reshift it. Maybe look for the defective part that we already talked about and change it. And then now we're at 1.364. Is 1.364 in between our upper and lower control limit? Yep, we're all good. So that's basically how we would walk through 11.13. The one piece of information is to understand what is an X bar and understand what is the standard deviation expectation for this quiz, and then understanding how to go through in Excel and just process some of that information, add it to the charts and lines, etc. Hope this was helpful. A little bit long, but I kind of wanted to walk you all the way through it just in case.